Welcome to the magical world of periodic table of elements, presented by the FOJ Incorporated.
Alright, as we go through this presentation, it might be helpful for you to have a periodic table out in front of you. So if you want to actually get anything out of this, you should totally do that now.
You have 5 seconds.
3, 2, 1. How the periodic table works. First, you'll see the atomic number. That's the biggest, most obvious number on top of the little square that the element's in.
And this represents the number of protons in an element. The number of protons is what gives the element its identity. If you change the number of protons, you'll change into a completely different element, but you can change the neutrons or the electrons without any problem. Those are ions and isotopes. On to mass. The mass is the sum of the protons and neutrons, and the reason why the mass number under each element is a decimal is because there are a bunch of isotopes of each form, which is when some atoms have different numbers of neutrons, which give them different masses, and the atomic mass gives you the average value based on how abundant each of these isotopes are relative to each other. And the electrons are negligible because they really don't weigh that much.
So groups are the columns. It goes up and down, and periods go across from left to right. And when we describe the trends of the periodic table of the elements, it's definitely helpful to keep in mind what groups are going to do, what periods are going to do. That's how we're going to describe it. So, and that's something to definitely keep straight in your head. Groups are columns, periods go across. And as we look at the elements, in general, you can say that groups are going to be more similar than periods. And we'll find out why as we talk about electron configuration.
Now moving on to the different areas of the periodic table. The first group that is most important and most well known, I guess, would be the noble gases. They are the rightmost column, and it is composed of helium, neon, argon, krypton, xenon, and radon. These gases are gases, and they're extremely unreactive because they have their full 8 electrons in their valence shell, so they tend to not react.
Alright, moving on to the next slide, you'll see the metalloids highlighted in a nice purpley color. The metalloids are kind of what they sound like. They're not really quite metals, they're not really nonmetals, they're right along that line that divides the metals and the nonmetals. And that metal-nonmetal line should be found on your periodic table in a slightly different shade of purple. It starts on the left of boron, and it does a little staircase motion all the way down to the line between polonium and whatever starts with AT. So metalloids, just keep in mind, they go down a little staircase, and they have properties that are kind of in between metals and nonmetals.
Okay, now on the next slide, you see the transition metals. These ones are your generic everyday metals that you'll find around your house, like your parents' wedding rings, probs made of gold, AG. There's nickel, magnesium. These are just your generic metals. They
Form funky ions.
They form really weird ions that you can't really describe ever. They're usually +1 or +2. They're very conductive because that's a property of metals, and it's pretty much what you know, and if anything's going to be colored when in solution, it's probably going to be from this block.
Exactly. Thank you, Sarah. Now, moving on to the alkali earth metals. These are the metals that are toward the left side. They're in the second group, and they should be highlighted in light blue. These metals are notable because they tend to form ions fairly easily. They become 2+, so you would have Mg2+, Be2+. They give away 2 electrons because they want to be back at that nice octet stage, so they can look like a neon, say. But they aren't really neon because their protons didn't change. So these alkali earth metals that's pretty much what you need to know for freshman chem. You'll learn a little more about them in AP Chem if you choose to take it, talking about little differences. Some funky stuff happens between calcium and strontium, and Sarah's going to edit this part out anyway, so I'm going to stop talking. Bye.
All right, so now on to the alkali metals. These ones are probably the ones that you'll use the most, I think, during chemistry in general, because you have your good old NaCl.
They're fun.
They are fun. Well,
Sociable.
they are really sociable. Well, not exactly NaCl, because that's when it forms a compound. But you have your good old sodium, potassium. These are the ones that are highly reactive with water, and they're really just the most fun to play with and deal with. They form +1 ions, if I didn't already say that, and they're just, I just really want to throw some in water right now. It's pretty much the sum of this.
They're so close to octets.
Yeah, they just can't wait to get rid of that one extra electron. They do explode. It's pretty magnificent overall. You can probably look that up on YouTube. Yeah.
Don't smell this.
And this is the, these are the groups, the alkali metals, alkali earth, transition, metalloids, and noble gas. Yeah, definitely important. Know those.
All right, now we move on to periodic trends. There are 3 trends that you're going to study in class this year: atomic radius, ionization energy, and electronegativity. If you can remember these, it'll be really helpful when you start thinking about reactions and other chemical processes. First, radius goes in the direction of the radius getting smaller as it goes to the right. This sounds really counterintuitive, and it takes a while to get used to, because you think, oh, there's more stuff, there's more mass, there's more electrons, more protons, so obviously it should be bigger. But it doesn't get bigger. It gets smaller, because the extra protons and the extra electrons are actually attracted to each other. And since most of the space in an atom is just empty space, like as I said, the electrons get pulled in closer because of the extra protons. So the atomic radius is actually smaller as you move to the right along the period. The second part of atomic radius and the trends behind it is a little more obvious. As you move down the periodic table, the elements get bigger because you have an extra level of electrons. You have a whole nother shell on the outside. So that's pretty much atomic radius in a nutshell. No pun intended.
That was a good one.
Thanks, Sarah.
All right, so ionization energy. This is the energy that is required to pull an electron off of an atom or element, or both. It will increase as you move across the period to the right, because as those shell thingies, those valence shells, when there's like 7 electrons, it doesn't really want to give up an electron, so it requires a lot of energy, but it in fact wants to take one in. So that's why the elements on the left side of the periodic table have very low ionization energies, because it's easy to just pull one off. However, also noble gases tend to have the highest ionization energies because they have a full satisfied electron shell, and they don't want anyone to pull it off. So if you want to, you just have to put in a lot of effort, aka energy. And as you move down the periodic table, ionization energy decreases because these electrons are getting further and further away from the proton, so there's less attraction, thus it takes less energy to pull an electron off.
Electronegativity measures the relative attractiveness of an electron to an atom. So the most electronegative element is fluorine, and the least is francium. Electronegativity increases as you move up the periodic table and as you move to the right along the period.
Which is the same as ionization energy.
Yeah, and that makes sense if you think about it, because an electron that's really, really attracted to its element is going to be very hard to take away or ionize. So they're exactly opposite.
And so this is the periodic table in a nutshell. Remember that radius gets smaller to the right, ionization energy and electronegativity increase to the right, and try to remember some of the general properties of all those group things we taught you. And groups go up and down, periods go left and right. This has been another production of FOJ Incorporated, presented by Sarah and
Alison.
Yay! No, go be smart. Okay, bye.